So that is an example of a hierarchy. If we consider the data as a kind of network, it's called a network database. Or if we consider the data as object that you learned in your object-oriented programming concept, this is called object-oriented database model. This is called the network database model. This is the hierarchical database model. However, in our class, we will consider data as what? It's what is our goal? What is our goal to manage the data? We need to access data very fast. But the hierarchical database is such a problem. Sometimes fast, sometimes not. Okay? Then, when we especially have the very large database, it's very hard to manage, access to such a data. So, our idea is, why don't we consider group of data? Instead of taking care of the individual student, I consider group of student, that is the student. For the student, each student has different characteristics, but I don't care. Instead, only common information, name, ID, and grade. Name, ID, and grade. Even though he is majoring in the electrical engineering, double major, in my database, don't care. Okay, I don't care. Only name, ID, address. Why? If I need to consider individually, my brain will be exploded. Okay, more complicated. Instead, just when I regard student as name, ID, address. So grouping. Grouping is actually the main idea of this. So at the time, this grouping is the same concept as the set. So is it true? A plus B is equal to B plus A. A and B are in natural number. Is it true?
Yes.
Did you test all the cases?
Not all cases.
Not all cases. How do you believe that is true? K-mean? What is the K-mean?
Like I tested for like 2-3 cases and
2-3 cases. Then so whenever you encounter problem, just test the 2-3 cases. You have a date with your girlfriend. Just ask a couple of questions. Then she love me. No. How do you believe? How do you believe that's a commutative, associative, whatever, distributive? How do you believe that is true for all the cases?
There are different types of proofs. You can use one type of proof.
What then? Let me change the question. Why we cannot prove such a case by case? It's an infinity number. Number is infinity. That is a problem. Okay? If that is a finite number, we can test all the cases. However, it's an infinity number. How can we deal with the infinity number? 0, 1, 2, 3, 4, 5, 6, and forever. Just mentioning the older number, then my life will be gone. Instead, we define. This is a natural number. Natural number what? This is a set. So we can define set, natural number, or real number, or the rational number, number set. Then, no matter how many data elements here, we group in set. Then, any number in this number has the blah blah blah. Okay, actually you can prove. For example, 8 times 0 is 0. You can prove. Okay? Why? Because we define such a set of the number. Similarly, when we have a lot of data, why don't we consider group of data? Actually, that is from concept of set theory. So this idea of using the set theory makes the computer manage the huge, this idea proposed, it's ready to address the problem of the very large data. Okay? So this is a grouping, this is a set, but in this class, and not actually this, not only database concept, this is called relation. Because they are related. So when this idea was proposed, by whom? Dr. E.F. Code. Actually, not only him, but there are several other colleagues, but the mostly is known that Dr. E.F. Code proposed this idea. Okay, at that time, we can use the set, or we can use the group, but we use him name as a relation. So relation is the exactly same concept as what? Set. You can think about set. Then we actually use a lot of the property and characteristic of a set for database model. When did you learn the set? Middle school? Even elementary school you learn, because set concept of set is the most important part of, it's kind of foundation of mathematics. So if you are majoring in the mathematics, you will take the probably set theory, either freshman level or the sophomore level, like the data structure class in computer science. So that is the relation, that is a set, that is a grouping. By naming, it's called the relational database model, which means there are several constraints and rules. So here we have something relational model database. So today we are going to talk about this relational database model. Okay? In other words, we will learn what is the rule, what is the concept, what is the constraint of the relational database model. Okay? I suggest, even though you have used the relational database like the MySQL, SQL Server, or whatever, forget about that. Okay? That will be easier to understand the concept of the relational database. If I'm asking right now, what is a primary key? You never heard about the primary. Okay? You don't know. Okay? That we will talk about such a concept of the relational database. Then, if we have this one, so we already did this. And this is a database model. Okay? What next step, after we discuss about this one, next step will be change ER model to relational database model. Then, after we finish this one, it will be practically create. It's a physical database model. Physical database model. Okay? So we will do this one and this one later. Today we are going to discuss about the relational database model. Okay? Before we start, let me show you this. As I mentioned, actually the idea was proposed by the Dr. E.F. Code in 1969, then published in 1970. This is one of the best paper in computer science history. Okay? So most cited one, and also it's one of the best. Title is the relational model for large shared data bank. You can see the large. That was the main problem. If that is not large, which means small, as we discussed in the chapter 1 and 2, we don't have to use the database. Instead, memory based, which means programming. In your programming, integer I, or the character name, that's pretty much okay. Or you can use file system. However, when we have, but at that time, large was large, but nowadays actually it's a very small amount. If we consider how much large for the relational database, nowadays it's up to petabyte. Terabyte, it was I think 20 years, 10, 15 years ago, it's a terabyte size. Relational database can manage up to a couple of petabyte size, several petabyte size, the database. If we have the bigger than such a level, relation in terms of theory, theoretically it can manage the infinity, but practically there might be like the performance, the flat, so around several petabytes. So above that size, like the 100 petabyte or the exabyte, such a database are called big data. Then in terms of the database concept, we need a different database model. That is your NoSQL database. Because we can consider that this now the most popular database as a SQL database. Because SQL is kind of representative, the function, the language to access data, relational database. But NoSQL means not only the SQL, but we have many other ways to address the size of amount of. Always we are fighting with the size of the data. Okay, the more data we have, it's less performance, obviously. So big data and the NoSQL database will deal with such a thing. But we go back to still the relational database is the most used relational database model. So Dr. E.F. Code proposed this. This is a paper you can find with. I think that I read this paper 20 years ago, but after that I never read. But not worthwhile, but worthwhile to see the formatting or writing, how to explain. It's not like the database textbook. So you will see the how to write such a thing. And he's the E.F. Code from when he was in the IBM T.J. Watson Center. It's nearby. So here, the White Plain. It's I think the 45-minute driving distance. But unfortunately, when he proposed this idea, he was in the IBM. But IBM has the more powerful database at the time. It's a hierarchical database. So hierarchical database still used, and IBM believed at the time relational database will be useless. So they start to implement the relational database management system, which is called the System R project, but stop sometime. Then some of the employee or researcher at the IBM, they believe the relational database will be more powerful. They quit the job and try to build their own relational database based on this idea. Then eventually version up. Later it will be Oracle database. So actually Oracle database from the IBM employee. And they nowadays one of the biggest software company who can compete with the Google, the only software company who can compete with the Google. They are not very good relationship actually. There are a lot of lawsuits each other and fighting each other. And the Google also not very familiar with Amazon. So it's a lot of things will happen. But anyway, so this is the database model that we are going to deal with. Okay. So what is first we are going to define what is a relation first. So idea is, as I mentioned, we are going to group it. Okay? Instead of taking care individually, grouping. Like we have Lee, ID, and address is 100 University and James, 112 ID, and 64 Main Street, and Bridgeport. And Pepper, 113, and Fifth Avenue, and New York. So we have, for example, this 1, 2, 3 data. Okay, when we take a look at this data, they have the common information, like this, whatever that is. Then we are going to define. This is a group of data. So this is called relation. In other words, this is we can name employee, EMP relation. Think about the mathematics, the set theory. How can you represent the set? There are two ways in your elementary school you learn. For example, 1, 2, 3, 4. X bar, X is condition, right? Bigger than 0, and X is the natural number, like the integer or something like that. There are two ways. So we consider this is the one element. Like the one element for Lee and so on. Another element, James. And another element, Arthur. So it's a set. Okay? So this is the code from now on, not a set, relation. So relation is a group of data. Sometimes each data is called tuple in terms of relational model. When you read the technical paper, sometimes like the data, but they say the tuple is a formal definition, mathematical definition, okay, notation. Also sometimes it's called, you are familiar with, row, data row, column and row. Especially the application program, like the DBMS, use the terminology like the row. Okay, so this is the tuple. So in other words, relation is a group of tuples. Also, group of data, group of rows. All of them are the definition of relation. By the way, I understand that this is the definition. So similar as the set theory. But when I see that this the group of data, each data has common information, like that this is the name. This is the ID. This is the address. Each and every tuple, each and every data has the same information or same column, same attribute. So we can define the relation as a group of attribute, group of column, group of information. So this is another definition. So relation, main part is the borrow idea of set. It's a group. So group of what kind of group? Group of data, group of row, group of relation, group of attribute, group of the column, tuple. So these are the definition, whatever that is. Then key part is we consider data as a group, not individually. Because of that, we can manage very large data. Because of that, actually, there might be limitation. Like when we consider the group of data, they should be common. Think about the object-oriented concept. Each object can be by inheritance. It can be different. Each student object may be different types of student. This one does not allow such a barriers. So identical format. So that is actually the idea of the relational model, and also that's the drawback, limitation of the data. Also, later we will talk about the details of constraint. Another constraint is each of them has the one value. Okay? What if it has the multiple value, like the multiple address? We don't know which one is which. We need to take care another data structure for this. Okay? So it will be the more complex. So because of that, it allows only one value. So that is a relation. So we are going to see the characteristic, constraint of the relational model. So one thing is, what if Lee does not have an ID? It cannot be part of relation. Because the idea is they have the identical same attribute, same data, but it doesn't have the ID to address that part. So do I need to take out? No. To keep it, we can use null. So null can be used to address such a problem. Because of that, you can see a lot of null in the database. So what about the NoSQL database? NoSQL database does not care that this one. It's very, very flexible. Some of the data has only name. Some of the data has the name, ID, address, and blah, blah, blah. It doesn't matter. It's more flexible. Because of that, it's sometimes semi-structured or unstructured data. Okay, but relational database should be identical. Because of that, we can use null in case we have missing information. Okay. Then another thing is, so this is a null constraint. That is called the null. Another thing is, what if? So this one is, it's called the key constraint. Before that, when we define each attribute, where do you get this one? There is a name has the kind of pool of name. Then this jar, big jar of the name has all possible person's name. Okay? So how many of them? It's not infinity, but almost like the infinity case of the name. Okay? And we have another jar and the ID. It's an infinity number, possibly the number. And we have the address. So big jar. So when we combine, when we make the one data, we can take out one of them. Take out one of them. Take out one of them. Okay? That is the one name, one ID, one address. Okay? We can take out the data and make the tuple. This is called domain. And this is called the domain, and this is called the domain. So because using this one, we can define, let's say the R represents the relation name. R is the subset of, and domain name. What is X in set theory? Cartesian product. Okay? And domain of ID, Cartesian product. Domain of the address. This is the definition of the relation, informal way. Okay? So for example, if we have the name, so name, one of the examples is Lee. And the ID, what is the ID? It's a 111. We take out ID. Address, 100 University Avenue. So this is the part of the relation. As an element in terms of set theory, in terms of relational model, it's called the tuple, one tuple. Then we can make the set of tuple. That is the definition of the relation. At the time, R represent the relation name. Okay? Then, this is the definition of the relation. Here's an example. So, we have the domain A and domain B. So, what is the possible relation made by these two domains?
7.
What about this one? Is it a relation or not? Yes, because 1A is possible. And what about this? Is it the domain? Yes, it is possible. Because 1A, so as long as it's a subset, it will be. What about this one? No, 3 is not here. So this will not be the relation of them. Okay? Then we can create the relation based on the domain. Okay, that's what Dr. E called proposed. However, have you ever heard about such a domain in the database? Probably not. So why? So somebody would like to implement Dr. EF code idea. So domain. Domain is just a big jar. Data. Okay? Full of the data that includes all possible names. How many names? Almost infinity. So we need huge storage. So it is not practically possible. So instead, they throw away the domain concept. Instead, they are using data type. So whenever we are talking about the type, it's kind of standardization. Standard, make the standard. Think about entity type in ER model. By grouping entity, we can make the student entity type. It's kind of standard. So when we implement the name, instead of all possible name, we can name as character 10 byte. Okay? Try to standardize using practical way. So we can use this one as a data type. So relational database model support some of the data type like the character, variable character, integer, number, and so on. We will discuss the details about such a possible data type. So very straightforward. It's very similar as what you know in the program language class. Slightly different, so we will see. So here, this is the original concept of the relational database. Picking up one value from each domain. Okay? But it's not practically easy to implement such a domain concept. We need to have the huge storage. Instead, we can use the data type. As long as this one satisfies with this data type, like the number, then that will be okay. This one is, instead of this one, is a character. Then it will be. So in the database model, we will use the data type instead of domain. Nowadays, some of the few number of relational database use the domain concept. Actually, domain concept is the correct. Like the name. Name is just the character less than the 10 byte. Is it the real? So any name can be less than the character 10. 10 byte character. Doggy name. Or the university name. Not only the person's name. Okay? But because of the some of the specialized database use the domain concept, okay, then it will not be error. So, for example, if I create a name like in error, A, E, is there any error if I type this kind of name? It will be created, okay, as long as it's recognized as the name. But it's not my name. It's not in the domain. But for practical reason, we use the data type. Okay, so any question regarding to the definition of what is a relation? Okay, we have 10 minutes, so let me use the slide to speed up. Okay, so definition of the relation is like you can view the data as a table format, tabular, but before that, understand it's a group of data, group of row, group of whatever. Okay. So this is the example of the relation. If we are using the tablet style, like the table, it will be much easier because you are already familiar with such the representation. So group of tuple, so it's a student relation. Group of attribute, so it's a relation. What if we do not have office number? So do I need to take out this data? No, I want to keep it. But to make the same format, same attribute, we can use the null data here. Okay. Then let me quickly go over the definition of the constraint of the relational database. One is the key of the relation. It's almost the same concept as the key in ER modeling. What is the definition of the key attribute in ER modeling? Attribute or attribute that identify. In other words, unique. Okay. How many key attributes?
Maybe one or more.
One or more, or sometimes not. So that is the ER model, key definition of the ER model. However, in the relational database, each and every relation must have the key attribute. Okay, it doesn't make sense if there's no key. Okay, so that is the key of relation. We will see the little bit more details later. Then, if we define like the employee relation has name, ID, address, group of attributes, so it's also relation. At that time, this group of attribute is called the schema. I mentioned we already used the schema before. Schema is the description to describe our database. Okay, so that is our goal. At that time, we can use the name of relation and including number of attributes. A1 through AN, not infinity number, it's a finite number of attributes. Okay? Then this time not always, it's not case sensitive, but depending on the DBMS system, some of DBMS system apply the case, like you need to the uppercase and the lowercase are different, but most of the time relational database model is not case sensitive. However, we like to use the capital letter for the name of relation. Okay, attribute either the capital letter or the lowercase letter, it doesn't matter. But still, it's not case sensitive. Example of the customer is the customer ID, customer name, address, and phone number, something like that. Okay, then at the time, each of the data is called the tuple. Actually, tuple is come from the Cartesian product of the domain, number of domain. Practically, we cannot use, instead, we can use later, data type. So we will see what kind of data type are supported. Okay, so that is the definition of the domain. Okay, then finally, if we have the schema, like the number of attributes, and also number of tuples. That is called do you remember the database state? It's a schema plus instances. Same thing. Relational, the schema plus the tuple, that is called the relation state. Okay? This is a formal definition, which we don't like. It's a mathematical way, but right now you can understand. So each tuple is a subset of domain, their Cartesian product. Okay, so that is a schema and the attribute. This is the example what we tested before. Okay. So if we add one more tuple, that is called sometimes population or extension. Okay. So this table shows because still. Even though I asked you to forget about your knowledge or experience working on the database, but still many of the students are familiar with the concept of this one, like the table, or the column, or the row. So this is a comparison table, the formal term or the informal term and formal term. Formal term means from academia. Academia use a lot, research paper or technical paper. On the other hand, informal terms are used